Hi everyone, welcome back to my channel. In today's video, we are going to talk about one of the most fundamental algorithm in machine learning, that is logistic regression. Before jumping into the code, let me quickly explain what logistic regression is and how it works. Logistic regression is a statistical method used for binary classification problems where the target variable has only two possible outcomes like 0 and 1, unlike linear regression which predicts continuous values. Logistic regression predicts probabilities that are mapped to binary outcomes using a sigmoid function. The sigmoid function ensures that the output stays between 0 and 1, making it ideal for classification tasks. It is commonly used in applications like spam detection, medical diagnosis, and customer churn prediction. So now that we have a basic understanding of what logistic regression is, let's dive into the code and implement it step by step. First, we import the necessary libraries. Here I am using NumPy and Pandas for data manipulation, Matplotlib for visualization, and the machine learning tools come from sklearn. Especially we are importing functions for splitting the dataset, scaling features, creating the logistic regression model, and evaluating its performance. Step 2, loading the dataset. Next we load the iris dataset using load iris function from sklearn.datasets. This dataset is commonly used for machine learning practice and contains measurement of flowers in 3 classes. Then, to make this a binary classification problem, I filter the data to include two classes, class 0 and class 1. This is achieved by removing rows where the target value is 0. After that, I separate the features into X and the target into Y. I then split the data into training and testing sets using train test split method. Here 70% of the data is used for training and 30% is kept for the testing. Also, this ensures we can evaluate our model on unseen data. Feature scaling is important for algorithms like logistic regression to perform well. I use standard scaler to standardize the features in both the training and the test sets. This scales the data to have a mean of 0 and a standard deviation of 1. Now I create the logistic regression model using logistic regression method and train it on the scaled training data using the fit method. This step essentially builds the model by finding the optimal weights for the features. After training, I use the model to predict the target values for the test data with predict method. The predicted values are stored in ypred. To evaluate the model's performance, I calculate the accuracy using accuracy score method and print it. In this case, the accuracy tells how many of the test predictions match the actual target values. Finally, I visualize the confusion matrix using a heat map plot. I use plt.matShow method with the cool warm color map to create the visualization. Now let's take a closer look at the confusion matrix plot. The confusion matrix is 2 by 2 grid because we are dealing with a binary classification problem. The rows represents the actual classes and the columns represent the predicted classes. In this case, the confusion matrix values are as follows. The top left value 17 indicates the true positive instances of class 0 that were correctly predicted as class 0. The bottom right value 13 indicates the true negative instances of class 1 that were correctly predicted as class 1. The top right and bottom left values, that is both are 0, which means there were no false positives or false negatives in this case. The model performed perfectly on this test case as predictions were correct. This reflected in this plot. The brighter diagonal cells indicate correct predictions, since the off diagonal cells are empty, that is dark, it shows no misclassification. This type of visual representation is incredibly helpful for evaluating classification models because it highlights both the strengths and the weaknesses of the model. In this example, our logistic regression model worked perfectly with the given data. And that's it for today's tutorial on logistic regression. I hope this explanation and code walkthrough were helpful. If you enjoyed this video or found it helpful, don't forget to like, comment and subscribe for more machine learning tutorials. Let me know in the comments if there is a specific topic you would like me to cover next. Thank you for watching and I'll see you in the next video.